Hello, and welcome to a video brought to you by the Answer series. In this video, we will be continuing with circle geometry, but this time we will be including tangents. As always, we are going to start by making sure that we know what we've been given and how we can use that information. So we're going to start with the fact that PON is a diameter. When we underline that on the sketch, we don't stop there. We actually take the fact that we have a diameter and we ask ourselves, what could we do with that? What would be useful? And that right angle is a direct result of the diameter because the diameter always subtends a right angle. Just out of interest, if you look at the angle in the straight line, it's 180 degrees. And it's one of the easy ways to understand why the angle on the circumference is 90 when you're coming from a diameter perspective. All right, the next piece of information that they're going to give us is TM as a tangent. We're going to go to the sketch, we're going to highlight the tangent. We're going to be very careful and not use the same color because then we get the impression that we have parallel lines, which we do not. So to avoid confusion, think about the color you're using if you are working in color. And it is a very good idea to use color in geometry. It helps things to stand out. The next piece of information is something to do with parallel lines. So we go to the sketch and we mark off OR parallel to PM. Again, we might not need this information later, but as you notice things, process them because everything that you pick up reading that given information is going to help you as you dig into the question and start answering the details. If you don't know why those angles are equal, if it doesn't jump out at you, it would help if you went one step further and highlighted the back of that F so that you can see the shape. Any F shape, the corresponding angles are equal, providing the lines are parallel. Finally, we need to look at the angle we've been given. It is the only angle they have given us, and we check that that detail is on the sketch. And now, as you look at that angle and where it's positioned, if you haven't thought about this before, you say to yourself, well, that's an interesting placement of the angle because there's a chord forming an angle with the tangent. So immediately, it should trigger the clue that we are going to use the tan chord theorem here because the angle between the tangent and the chord is always equal to the angle which that same chord, so this chord that we are working with, is incredibly important. If we take the chord MN, it forms an angle with the tangent on the one side, and it forms an angle on the circle on the other side. Those angles are equal because of that tan chord theorem. So in question 1.1, we have been asked to find the size of angle P. We have already figured out the solution, so we'll just go back over it one more time. Angle P is tucked away in the corner here. It connects a tangent at point M. Fundamental to how do I actually know when to use the tan chord theorem, if the line that forms an angle drawn back to the circle at M touches a tangent, then you go from that point back onto the circle, finding out where the chord is. And the angle that is formed between that chord and the tangent, which is 66 degrees, will equal the angle that the same chord subtends on the opposite side. So angle P is 66 degrees, tan chord theorem. It's very easy to write that up. You simply say angle P is 66 degrees, and the statement is short and sweet, tan chord theorem. In question 1.2, we need to find the size of angle M2. So if we have a look at the sketch, and because we can see that it's the angle that we worked with earlier, so we're simply going to double check. The angle is subtended by the diameter, so we can claim that it equals 90 degrees and simply write up our answer. So angle M2 is 90, angle in semicircle. In question 1.3, we have to find the size of angle N1. Now, angle N1 is on the edge of the circle, so we're not quite sure what our strategy needs to be, but we also need to think about everything we've done before. And regardless of the method that we end up using, it is often helpful to simply trace the sides of the angle so that you can get a better picture. And in doing that, I can see where the angle starts from, but I can also see that if I just draw in that line, I have a triangle in which I've already processed that angle M2 is 90, and that angle P is 66. So to find angle N1, I simply have to find the third angle in the triangle. So for 1.3's solution, all we have to write up is angle N equals 24 degrees, sum of angles in triangle. Question 1.4, we need to find the size of angle O2. So if we go to the sketch and remind ourselves of where that angle is, we could usually jump to the conclusion correctly that we would use the angle at the center theorem. But in this particular case, doing that doesn't really provide us with much assistance because Rn does not subtend any other angles on the circle or at the center, obviously. So we need to think differently. So now we need to look at our checklist and ask ourselves, what do we know that could be helpful? And what we know is that this line at PM is parallel to the line OR. And if we simply draw in that extra line, we can see the F shape, which triggers the corresponding relationship that we actually have. So it's misleading when you get an angle at the center. You can often jump to conclusions about angle at center theorems. In this case, we're simply going to use corresponding angles. Once you've identified the method, it's very quick. Angle O2 is 66 degrees. Corresponding angles, remember, you must name the lines that are parallel. OR parallel to PM. In question 1.5, we need to calculate the size of angle N2. So we're going to start by locating that on the sketch. And one of the most important things to do is to figure out how that angle landed on the circle. So trace the lines back that form the angle. It helps you to find the chord, even if it's invisible. You can draw it in yourself. Now you can see that the chord MR subtends the angle at N2. If we had additional lines, which in this case we don't, if we had a line going from R to P and from M to P, then we would have our bow tie effect and we would be able to use angles in the same segment. Or if we had a line from M to O, we already do have a line from R to O, then we could consider angle at the center theorem. But in this particular question, we don't get any help at all from going back and finding the angles in the same segment. We just can't use that theorem. So we have to go back to the drawing board and think again. So what else do we know? We know that we have a 24-degree angle available to us, so we could expand this and rather look at finding that whole angle. So the whole angle is part of a triangle, and the triangle has radii that are equal. So now we're onto something because we also know that angle O2 is 66 degrees. So we're going to look at the calculation. Angle R is equal to angle N, and that is because we have angles opposite equal radii. Okay, now we're going to calculate the size of each of those angles by taking a half of 180 degrees minus 66 degrees. And that is going to give us a half of 114 degrees, which will give us 57 degrees. So we know that angle N, rather named as angle RNO, is 57 degrees. So if we subtract 24 degrees from 57 degrees, we will get the answer. Now all we need to do is write that up properly. So starting from the beginning, ON equals OR, radii. Therefore, angle ONR equals angle R. So these two angles are equal. Angles opposite equal sides. We've already discussed the subtraction, so we can simply state the answer is 57 degrees. Don't forget the reason, angle sum of triangle. We don't need a reason on the last part because we are simply doing a calculation. So angle N2 is 33 degrees. That was a challenging question compared to the others in this particular example. All right, moving to example 2, we have a real challenge on our hands. And the key warning to that is the fact that we have a 7-mark question and no scaffolding. They haven't done anything to give us an idea of where to start. So we need to be very calm, very relaxed, and use our strategies that we've been developing over time. So what do we know? We know that we have a center point at O. We know that we have two sides that have been given to us that are equal in value. So we're going to mark off more boldly so that it jumps out at us, the fact that those two sides are equal. And we also know that they have given us the value of x as being the size of angle O1. All right, what we haven't really done is process what is it that we need to find. So before we go any further, we need to take this angle. We need to think about where it is, and we need to think about how we're going to use it. So angle STM is sandwiched between a tangent and a chord. And that means that we're probably going to use the tan chord theorem. So if we join the tangent up to the chord and then the chord to the circle, we can see that the relationship which we are most likely to use is the relationship between angle T1 and angle P1, because they are in fact equal. So we've pretty much gone through our checklist. We have thought about what we need to find. We know where it is on the sketch. What do we know that could be helpful? We'll put that into practice as we try the actual question. And can I justify my answer? So the challenge now is, what do we know that could be helpful, and can I justify my answer? All right, we've done a lot of thinking. Now what we need to do is start putting our thoughts into action. So what could we do that could be helpful? What do we know that could be useful? We take the circle theorem, we look at the angle at the center, and we start seeing if we can engage. Unfortunately, the angle that they've given us is not correctly placed to find angle M, because it's on the same side of the radii. In order to use the angle at the center theorem, we need the angle on the opposite side of the radii. That's not complicated. We're simply going to write this angle in as 360 degrees minus x. Now, that angle is correctly placed to connect us to angle M. So angle M is going to be exactly half of that. It's going to be 180 degrees minus a half of x. We also know that we have an isosceles triangle, so these two sides are equal, means that angle P1 will equal angle T2. So we are going to calculate our angles by simply doing the following. We're going to say angle T2 is equal to angle P1. And each of those angles is a half of the total sum of the triangle, 180 degrees, minus the angle that we already know. And the angle we already know is 180 degrees minus a half x. So if we can sort this out, we will have our answer. 180 degrees can be eliminated because it adds up to 0. The two negatives give us a positive. And so if we multiply that out, we get a quarter x. So the angle at P1 is a quarter x. And since the tan chord theorem links the angle we need to the angle that we have, we basically have our answer. We simply have to be able to justify it. So writing it up from the beginning, we start from the starting point. Angle O2 is 360 minus x. Angles around a point, so that's the angle we found here. Then we went to angle M and found the little angle inside. It is 180 minus a half x. Angle at center equals twice angle at circumference. We explain angles opposite equal sides. We calculate them at the same time because they are each a half of the difference between 180 degrees and the angle that we have. And all of that is based on the angle sum of the triangle. That gives us an end result of a quarter x. So using the tan chord theorem, we link angle STM to angle P1, justify, and conclude. And that brings us to the end of this video. If you have any concerns about this last question or any other questions, then simply go back to those questions, pause the video, have a good look, listen to the explanation again, and hopefully you will walk away from this feeling a lot more confident.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.